This is question number 10. I will have to draw the figure for this question. So let me do that. We got the x and y axis. Now we got a line x is equal to 1. Moving like that, and then we have y is equal to 1, another line moving like this. Now there is a curve that is actually drawn, so I will have to draw the curve. So curve is actually moving out like this. Okay, and this point is B, this point is A, this is B of 3/2, 1. Now if you see here, we have to obtain the volume of revolution. Now if you were to spin this, you will get an image which also includes a cylinder. So what they are asking us is, they want us to find the volume generated by the shaded region. So we will have to exclude the volume generated by the cylinder from this calculation. So that is a very important part we have to understand. So the requirement is, we are given this figure and we have to just find the volume generated when the shaded region is rotated about 360. So we are actually obtaining the volume of revolution. So we have to utilize this formula, and we have to exclude the volume created or generated by the lines. So that would be a cylinder. A cylinder would be actually generated. So we have to subtract from the original calculation. So that's a key point. Apart from that, this is a straightforward question. So let me write the question down over here. So this is the figure. The question is, the diagram shows part of the curve with the equation y is equal to 4/2x-1 raised to the power of 2. And so this is what I was talking to you about, and parts of the line x is equal to 1 and y is equal to 1. The curve passes through A of 1, 4 and B of 3/2, 1. And question A, find the exact volume. So that's a key word, exact volume generated when the shaded region is rotated through 360 degrees about x-axis. Okay, that's part A. Part B is a triangle is formed from the tangent to the curve at B. The normal to the curve at B and the x-axis. We have to find the area of the triangle. So a triangle is formed from the tangent to the curve at B along with the normal to the curve at B and the x-axis. So we have to find the area of the triangle. So this is a lovely question. Okay, so having given you the question, let me go and perform the solution. So now it's about the x-axis. So you see the figure, the limits are 3/2 to 1. So I'm going to write the formula here. So let me required volume. Required volume is equal to pi times integral x is equal to a to x is equal to b y squared times dx. So this is the formula. Now the curve is given. So this is pi times 1 to 3/2 y squared, that's 4/2x negative 1 raised to the power of 2. This has to be squared times the dx. Okay, so we have to integrate this. So let me write the integration over here. B is equal to pi times 1 to 3/2. So 4 squared, that is going to be 16/2x negative 1 raised to the power of 4 times dx. How do we integrate this? So what I'm going to do is I'm going to let 2x negative 1 is equal to t. So 2 times the dx is equal to dt. So dx is dt/2. This is equal to pi times, don't bother with the limits, just make the substitution. So 16/2x negative 1, that's t raised to the power of 4. Dx is dt/2. 2 divides here 8 times. So I can rewrite this as 8 pi integral. T is in the denominator. So you push it to the numerator. You get it like this. Now you integrate. This is 8 pi of t raised to the power of negative 4 positive 1. Negative 4 positive 1. This is 8 pi of t raised to the power of negative 3 divided by negative 3. Which is 8 pi divided by 3 with a negative sign. And you can push this t down so that you are going to get it like this. But my t is 2x negative 1, so make that substitution. So negative 8 pi over 3 1/2x negative 1 raised to the power of 3. Now you place the limits 1 to 3/2. So you substitute the upper limit, you get 2 times of 3/2 negative 1 raised to the power of 3 negative. You substitute the lower limit 2 of 1 negative 1 raised to the power of 3. Now 2 gets cancelled, 3 minus 1, that's going to be 8. So you have 8 pi over 3 1/2 cubed, that's going to be 8 negative 2 minus 1, that's going to be 1, and 1 cubed will give you just 1. Now you simplify this, so this is going to be negative 8 pi over 3. LCM is 8, so you get 1 negative 8, which is negative 8 pi over 3. 1 negative 8 is negative 7. You have a 8 here. 8 gets cancelled. Negative will become positive. So this will be 7 pi divided by 3. Now this is the volume that we have got it as a whole. So now to get the required volume, what you need to do is from 7 pi over 3 you need to remove the volume of the cylinder, which will be pi over 2. So if I were to take the LCM as 3 and 2, I would have 14 pi over here, 3 pi, and that would be 11 pi over 6. So this will be the answer, 11 pi over 6 cubic units. Now whatever unit you have got, you can place that. Now to answer question B, we are given y is equal to 4/2x negative 1 raised to the power of 2. Now we will have to find the slope at B. Find the slope at B of 3/2, 1. So for that I differentiate this. Now this would be a little bit challenging. So what I wish to do is I would like to take u to be equal to 2x negative 1. So this in turn would mean y is equal to 4/, u raised to the power of 2. So this is a chain rule. So therefore dy over dx is equal to dy over du times the du over dx. So this would give us the differentiation of dy over dx. Now differentiating this du over dx, that's going to be 2. Now this can be rewritten as 4 times u raised to the power of negative 2. You differentiate this dy over du, you get 4 times negative 2 times u raised to the power of negative 2 negative 1, which is negative 8 times u raised to the power of negative 3. So make the substitution. So this is equal to dy over du, that's negative 8 times u raised to the power of negative 3, du over dx, that's 2. This is negative 16 times u raised to the power of negative 3. But what is my u? My u is 2x negative 1. So substitute that 2x negative 1 raised to the power of negative 3. I can rewrite this as negative 16 over 2x negative 1 raised to the power of 3. Okay, so I did all these things just to show you how to implicitly differentiate this. So dy over dx is now equal to negative 16 over 2x negative 1 raised to the power of 3. Now we need to obtain the slope at the point 3 over 2 comma 1. So that means dy over dx is equal to negative 16 over 2 times of 3 over 2 negative 1 raised to the power of 3. So 2 gets cancelled, giving you negative 16 over 3 negative 1, that's 2 raised to the power of 3. So you have negative 16 divided by 8 divides here 16 2 times, so you have minus 2. So dy over dx is negative 2. Therefore the slope is m is equal to negative 2. Now let me find out the equation of the tangent at the point b of 3 over 2 comma 1. Right, so that's going to be y negative y1 is equal to m times x negative x1. So y negative 1 is equal to slope is negative 2 and you have 3 over 2 here. So you distribute negative 2, you get negative 2 times x, positive 2 times 3 over 2, that will give you 3. You have a y negative 1, so you push this negative 1 to the other side, you get y is equal to negative 2x positive 4. So this is the equation of the tangent. So let me write this down, equation of the tangent at the point B. Equation of the tangent, and that is y is equal to negative 2x positive 4. Now from here we can easily get the equation of the normal. So equation of the normal, that's going to be y is equal to x over 2 positive 1 over 4. Now we need to get the area of the triangle. For that the following steps has to be used. So foremost we get the x-intercept. Okay, now this is for finding the area of the triangle created. So the x-intercept, to get the x-intercept, put y is equal to 0. So I'm going to take this as 3 and 4. Put y is equal to 0 in 3. So you get 0 is equal to negative 2x positive 4. So therefore 2x is equal to 4, which means x is equal to 2. Now similarly, you need to get the x-intercept. So for that you put y is equal to 0 in 4. So this is 0 is equal to x over 2 positive 1 over 4. This means negative x over 2 is equal to 1 over 4. This means x is equal to negative 1 over 2. Right. So having got this, now we can get the base. So the base is obtained when you actually subtract the intercepts, the x-intercepts. So base is going to be, you take the first quantity 2 negative of negative 1 over 2. That's going to be 2 positive 1 over 2, which is equal to 5 over 2. So the base is actually got. Now we will have to get the height. The height can easily be got from the figure, and that is going to be equal to 1. So now the area of the triangle is nothing but, I'm utilizing this formula, half times base times height, which is nothing but half times the base is 5/2 and the height is 1 unit. So this is going to be 5/4. So therefore area of triangle is equal to 5/4 square units. So that is the conclusion for this question.